And now we look at section 7.1, which gives us the definition of chemistry. Chemistry is, first of all, defined as a science, but what it deals with are three things: 1, 2, and 3, which is composition, structure, and properties of matter. And what is matter is anything that takes space and has mass. So those two things is what is made up of matter. In other words, that's what matter is defined as: anything that takes space and mass. And then the other aspect of chemistry is to take a look at how matter changes under different conditions. So when we talk about change, there's two types. So one is we have physical, and the second is chemical. Physical change would be, for example, ice goes to liquid, goes to steam. So now we have solid, liquid, and gas states of matter. That's the first type of change, physical change. The chemical change is more permanent. So for example, if we have iron, which is Fe, in other words, we have a bike that is made out of metal, and it's out in the rain, and so there's clouds, and then rain comes down, and now what's happened to the bikes that's sitting outside? It becomes rusty. So the metal combines with the water, or combines with oxygen right here, and that oxygen is in the water, H2O, and so this oxygen hits the water, and what we get out of that is ferric oxide, FeO2, ferric oxide, and that is called rust. Okay, and that is a permanent change. So we do talk about physical change, and we talk about chemical change, and that's the concept of change under different conditions. In other words, if it's freezing, there's ice. If it's kind of normal room temperature, as in California, then we have liquid. And then if there's very, very hot, like in Texas, water quickly begins to evaporate and becomes steam. So the certain concepts. Now, last thing that we want to take a look at in this introduction of chemistry is that there are two branches of chemistry, and that's the next thing that we'll take a look at. The first branch is called the organic, based on life and living matter, or substances derived somehow from living matter. And then the on contrary to that is the meaning not organic, so inorganic material as well. So those are the two branches of chemistry, and that it definitely is a test question. One is the organic, and the other one is inorganic, and we'll take a look at that in more detail next. Here's a review. So when we talk about chemistry, it is a science that looks at matter and the aspect of matter. That what is matter, first of all, is anything that takes space and has mass. Now, in the matter, the chemistry aspect of it, there's a focus on composition, structure, and properties of matter. And then another aspect is to take a look at how matter changes. So types of changes, and we did talk about two types of changes. One is physical. The other one is chemical. And then the other aspect of chemistry is there are two branches of chemistry. First is organic chemistry. And organic chemistry are where substances that we are dealing with, chemicals that we are dealing with, are derived from once upon a time living things. So anything that was living once upon a time, from that some substances come. These chemicals come and have the basis in the living substances. In contrast to that, we have inorganic chemistry. So let's look at that more in detail. First of all, we have organic chemistry. Organic chemistry, as it says, is the study of substances that contain the element carbon. This is very important because all living things, whether they are plants or animals, contain carbon. So carbon is the key thing that distinguishes organic chemistry from inorganic chemistry. Organic chemistry has carbon in it. Inorganic chemistry is a branch of chemistry dealing with compounds that do not contain the element carbon. So the carbon is absent in that. Now, although the term organic right here is often used to mean safe or natural because of its association with living things, the term also applies to anything that has ever been alive. So while we do talk about living things as organic, we are also talking about compounds, something that we derived from what were once living organisms. So here's something: gasoline, plastics, synthetic fibers, pesticides, and fertilizers are all derived from living substances or once living substances, and for that reason they are called organic substances. These products are manufactured from natural gas and oil, which are remains of plants and animals that died millions of years ago. Organic compounds are flammable and will not burn. I'll erase everything and focus on, first of all, three things that organic chemistry must have the element carbon in it. It is derived from what were once living things. And the third thing is organic compounds are flammable and will burn. They're combustible. And so combining with oxygen and heat, they will go up into flame. And some are readily flammable. In other words, that doesn't take very much. For example, gasoline, very quickly combustible, and other substances may take a little longer or stronger heat for them to turn flammable, but will burn. And then in organic chemistry, we talk about inorganic substances are not flammable. In contrast to organic, inorganic are non-flammable and will not burn because they do not contain the carbon. And so carbon is an essential element in that combustibility. So inorganic substances are not and never were alive. So they were never ever a part of a living organism. And so metals and minerals and glass, pure water and air are examples of inorganic substances. So there is the organic and the inorganic chemistry differences. First is carbon, and then second is living things, and third is combustibility.